Set up the integral to calculate the area between the following curves, y equals 6x squared and y equals 4 root x. So how do we do that? We have the answers here, but how did they come up with that? Well, step number one is find where they intersect. So, gotta do that. So how do we find out where they intersect? We set them equal to each other. Take this one and this one, set them equal. They're going to intersect where they hit each other, where they're equal height, where the y values are equal. Now, how do we solve that equation for x? It's kind of a tricky one. Yeah. So what you should do is bring this over here. So you get 6x squared minus 4. I'm going to make this x to the half power equals 0, like that. And now what you want to do, so step one, say step one, get a 0 on one side. We did that. Step two, factor out lowest power. Didn't do that very well. Power of x. And take out the lowest power of x. See, look at these guys. Who's the lower power? X to the half, right? That's lower than 2. So, well, what goes inside? Don't worry. And you might think, well, 6 and 4, who cares? I don't care about the numbers. That doesn't matter. This needs to be x to the 3 halves. How do I know? Because when they multiply those powers out, 1 half and 3 halves will make 4 halves, which is 2. Do you see that? Minus 4. You see, if I distributed this, it would go right back to these two guys. Again, when these multiply, the powers will add. So what you could do, let's make them decimals. That'd probably be easier. So what if I just say, look, this is 0.5 instead of a half, and then this is going to be 0.5 because that's the 0. I'll just go 0.5, 0.5. That's a lower power. So this has got to be 1.5, doesn't it? Right? Because this is x to the 0.5. Is that easier? Because then the 0.5 and the 1.5 add back to be 2, don't they? Remember when x is multiplied, powers add, and then this multiplies to go back to 4x to the 0.5. Yeah, that's easier. Okay, so factor that out. Okay. And then step 3 is you set each part equal to 0 and solve, right? Because if two things are multiplying t, so what if I said, hey guys, I'm thinking of two numbers. One number times another, so say one number times another number equals 0. What does that mean? Well, the first number could be 0. 0 times anything like 0 times 3 or whatever would be 0. Or the second number, it could be like 5 times 0, and that would equal 0, right? So the first one could be 0 or the second one. Either way, they're going to multiply to be 0. So that's why we set each one equal to 0. It's just logical. So the first one, x to the 0.5 is 0. Or the second one, 6x to the 1.5 minus 4 is 0, right? If two things are timesing to equal 0, that means the first one could be 0 or the second one could be 0. Either way, they're going to multiply to be 0. So how do you finish this one? Well, it might help you to see it if you go back to this is a root x. That's what that really is, right? It's a root of x. And so what do you do there? You second power both sides. Remember, a half power is a root x. So then second power both sides, so x is just 0. Now on the other one, a little more tricky. Let's move the 4 over. 6x to the 1.5 is positive 4. And then divide by the 6. Boom. So x to the 1.5 is 4 6. Also, if you make it 2/3, whatever, who cares? So now, how do I finish that? In fact, actually, let me go back. Let me just keep it green. I don't know why I changed colors. It was not well done. So let's try that again. So 6x to the 1.5 is positive 4, and then divide by the 6. Okay, so x to the 1.5 is 4 6. Now, the whole question is, how do you get x when you have a weirdo power like 1.5? What are you going to do? What are you going to do? Well, what you do is you just you raise both sides to the 1 over 1.5, right? Because this is over 1. These will cancel, just be x to the 1, which is normal x. Does that make sense? You want to solve for x, and x means normal x means x to the 1 power. So you think, what do I do if I have a weird old power like 1.5? You put one, you raise it to the 1 over. These can't cross cancel. Whatever you do to one side, you have no choice but do the other. Now, what's that answer? I don't know. I'm going to go to Desmos and find out. 4/6 to the 1 over 1.5. Let's go to Desmos. 4/6 to the 1 over 1.5. So I'll go parentheses 4/6. Oops, didn't do that very well. 4, um, 4/6 to the power 1 over 1.5. There we go. Boom. 0.7631. 0.7631. That's where they intersect, and this one was 0. By the way, we could have done that same thing here. Let me show you. Okay, could you done this here? Yeah, you could have. So that same idea. You could say, look, so I have x to the 0.5 is 0. Are you saying, Mr. Heron, that we could just raise this to the 1 over 0.5? Don't need to. Yeah, totally. Because these will cancel, right? This is over 1. They'll multiply and cancel. So you get x to the 1, which is just normal x. And what is 0 to the 1 over 0.5? Well, 0 to any power is just 0. It's going to be 0. So there's our two intersection points. There's the two places that these graphs intersect at x equals 0 and at x equals 0.7631. Okay, that's all step 1. All we've done now is step 1. Now we're on to step 2. Step 2 is find which function is on the top and which is on the bottom in the middle. We know they meet at those two places, but in the middle, which function's on the top and which one's on the bottom? How do we figure that out? So what we're going to do is we're going to plug in an x value in the middle to both functions. That's what we do. So I'm going to take both functions. What both functions? This function and that function. 6x squared and 4 root x. So I'm going to take, okay, y equals 6x squared and y equals 4 root x. Okay, I'm going to plug something in the middle. Now, what's in the middle? Well, let's just, maybe I'll go down, or maybe yeah, I can go down here maybe. Let's do a nice little number line on that. That'll help. So I'm going to go boom. And I'm going to go, okay, I'm going from 0 to what? 0.7631, right? From 0, they meet at 0 and at 0.7631. So because of 0.7631. See them right there, 0 and 0.7631. So I got to plug something between those two. What's a number somewhere in the middle? It doesn't have to be exact one, somewhere in between them. That'd be something like, how about 0.5? How about 0.5? Or you could do 0.4, 0.3, anything between 0 and 0.7. So 0.5 is in there. So we'll do 0.5. So I'm going to plug in 0.5 to this function. 0.5 squared. I'm going to plug in 0.5 to this function. Oops, 0.5. What are those? I have no idea, but Desmos does. Here we go. 6 times 0.5 squared. Let's go to Desmos. 6 times 0.5 squared. 6 times 0.5. 6 times 0.5 squared. That one's 1.5. That's 1.5. So this one comes out 1.5. Let's do the other one. Do this one. 4 times the square root of 0.5. That is the function, right? Yeah. Right, y equals 4, yeah. 4 times square root of 0.5. Let's do it. 4 times the square root of 0.5 equals 2.8284. 2.8284. 2.8284. So which one's higher up? Well, this one's on the top. Oh, he's higher. This one's on the bottom. In the middle, at least, right? So that means the 4 root x, this function is the top function, And this function is the bottom. Now, do you know what they look like? You don't have to know a lot, honestly. Yeah, let's just leave it at that for now. So that's pretty much all I need to know. I can come up here and do my integral now. I'm gonna go, and I'll do it. I don't know where to do it. I'll start right here. Integral, and maybe I shouldn't start there. Let me just add a page here. Okay, so it's going to be the integral from left to right. So think about what we're doing. We're going to stack up a bunch of rectangles, right? See how the original integral said dx? We're going from left to right. Yeah, so I'm just going to tell you the four root, you know what the 6x squared function is. That's a U shape going up, right? You know that's a U shape like that because it's x squared is always a U shape. It's positive 6x squared, so it's a U shape going up. This one is a square root graph. You might not remember what square root graphs look like, but they look like that. They do that kind of thing. So that one, I'm just going to do that one right here. That one's doing something like that. Okay. Well, I should do an arrow there. They meet there, don't they? They intersect there and they intersect there. And the other one is doing a U shape. So I'll just say, well, it's doing some kind of U shape like that. And again, it meets, they meet there and they meet there. And I knew which one to put on the top, right? So this is wrong color. This is y equals 4 root x on the top. And the bottom one is y equals 6x squared. I checked it out with the table and found that out, right, by plugging them in, right? 2.8 is higher than 1.5, so this one's on the top. So then what are we going to do? We're going to put in a bunch of rectangles, right? We're going to find the area by putting in a bunch of rectangles and add up, sum up a big S. That's what an integral is. It's a big sum of a bunch of rectangles. And for each of these rectangles, what's the area for each of these rectangles? Well, the width is dx. So I'll just put that right here. Dx is the width of the rectangle and the height of the rectangle. The height of each rectangle is going to be the top minus the bottom. That's how you find the height. So top minus bottom. So it's the integral of the height. You know, each rectangle's height times the width. That's how you find the area of a rectangle, height times width, which we know is top minus bottom. That's the height. Times the width, which is dx. And so that means it's the integral from, what's the left and the right? The left is 0. The right is that 0.7631, 0.7631 of the top function. What's the one on the top? 4 root x. So I go, okay, 4 root x minus, what's the one on the bottom? It's right there. The one on the bottom is the 6x squared. Boom, boom, dx. So there it is. There's, that. We're not going to calculate the integral. You did that in earlier sections. We could do that. We just don't want to make these too long. There's the integral that will come up with the exact area between those two curves where they intersect. Let's double check our answers right. What would they get? 7631, 4 root x minus 6x squared. 7631, 4 root x minus, yep, that's exactly right. Here's the actual picture. I graphed it on Desmos if you want to see. There's what it actually looks like more precisely. See the U, there's the root x graph. It's the blue one, 4 root x. And there's the parabola, the 6x squared. See, here's where they intersected 0 and 7631, just like we said. And here's the area of the region between them. Looks a little different than my made-up graph, but that's the real deal. And so that's how we find the integral in the area between them. And there we go.